Okay, you know all the AI that feels like magic in your daily life? Well, it's not magic. Under the hood, there's this hidden engine, this kind of secret language that lets machines actually make sense of our world. And today, we're going to decode that language. We're talking about representation learning.
So, just how big of a deal is this one idea? Well, let's start with what it actually does, because you're already using it all the time, probably without even realizing it.
I mean, just think about it for a second. When you talk to your smart speaker, it doesn't just hear sounds, it gets what you mean. When your phone organizes your photos, it's not just seeing a bunch of pixels, it's recognizing your friends' faces. You've got AI that can translate languages, create music. It's like it has a real grasp of our reality.
But that right there is the million-dollar question, isn't it? How on earth does a machine, a thing that only thinks in ones and zeros, learn to get something as complex and human as sarcasm in a text message, or, just the basic difference between a cat and a dog?
To get that answer, we actually have to take a little trip back in time. We need to look at the old way we tried to do this. And it turns out we used to have to do pretty much all the thinking for the computer.
Yeah, this old-school method was called feature engineering. Imagine you had to teach an AI to recognize a face. You, a human expert, would have to sit down and manually write code for every single tiny rule. Things like, okay, the distance between the eyes should be this, or the curve of a nose looks like this. It was just incredibly slow and totally limited by whatever the human expert thought was important to look for.
And this chart, it really lays out the massive shift. We moved from that old way, which was super slow, brittle, and totally bottlenecked by human experts literally hand-coding everything, to this new way, which is automatic, it's fast. The AI isn't being told what to look for anymore. Instead, it's learning to find the important patterns all on its own, even patterns a human might never have thought to look for.
Okay, so that's the key, right? This whole new world is built on the machine learning a good representation of data by itself. But what does good representation actually mean?
This right here, this says it all. To a computer, a photo is just a giant grid of pixel values. It's a wall of meaningless numbers. A good representation is the incredible leap from seeing those raw numbers to actually understanding the concept, a person at a beach during sunset. The AI has learned the idea behind it, not just the data points.
So what makes a representation good? Well, researchers have figured out a few key ingredients. We're going to focus on the two most important ones on this list, hierarchical and disentangled. But really quick, sparse just means only a few things are active at once, keeping it efficient. And smooth means that tiny changes in the input don't cause a massive, crazy change in the output.
First up, hierarchical. This is so cool. It basically means the AI learns in stages, kind of like how a person does. The first, most basic layer might learn to see simple stuff from the raw pixels, like edges and colors. Then the next layer up combines those edges into simple shapes, like circles and lines. The layer after that combines those shapes into objects, like an eye or a nose, until finally, at the very top, it can see the whole face. It builds complexity, one step at a time.
And second, we have disentangled. Now this is a total game changer. It means the model learns to pull apart the different factors that make something what it is. It's like the slide says, imagine the AI has its own internal mixing board with separate sliders for an object's size, its color, its rotation. This is a huge leap because now it's not just recognizing a car, it's starting to understand the very attributes that make up a car.
Now this all sounds absolutely incredible, but for decades, it was mostly just a theory. We just didn't know how to train AI models to learn these kinds of amazing representations. It really took one major breakthrough to unlock everything we see today.
And this timeline shows that exact moment. For years, these deep, multi-layered networks were powerful on paper, but in the real world, they were basically impossible to train. People thought it was a dead end, and then 2006 happened. A new training method let researchers train these massive models one layer at a time. And that single idea, that one innovation, completely revitalized the entire field and kicked off the AI revolution we're living through right now. And this wasn't some tiny little improvement either. This breakthrough blew the doors open for everyone. It allowed two huge schools of thought, the brain-inspired neural networks and the statistics-based probabilistic models, to finally come together and build on each other's strengths, leading to this just massive explosion in what AI could do.
So we've seen the old, manual way, and we've seen the new, automatic way, with its smart layers and its disentangled concepts. But let's just zoom out for a second. What does this all really add up to? Because this is about so much more than just building better tech.
This right here. This quote from the pioneers of the field is maybe the most important takeaway of all. Learning good representations isn't just some clever programming trick. They argue that it is a fundamental requirement for any machine that even hopes to understand our world. It's not optional, it is the whole ballgame.
And here's why that's so incredibly powerful. Once an AI learns a good, solid representation of the world, like it learns what an edge or a texture is by looking at a million cat pictures, it can then transfer that basic knowledge to a completely different task, like identifying cars. It doesn't have to start from zero and relearn the basics of vision every single time. It builds on what it already knows, making it so much more efficient and flexible, a lot more like us.
Which really just leaves us with one final fascinating question. For decades, we've been trying to teach machines to see the world through our eyes, but now they're starting to build their own representations of it. As this secret language of AI keeps evolving, what new things about our own world will it end up revealing to us?